Good afternoon. My name is Ben. I'm at the New York Times on the crossword puzzle team. If you want, you can follow me on Twitter. My handle is BenLikesToCode. And we're going to talk about Android architecture for the subway. So why the subway? Well, you get on a train, you get underground, you don't have data service. So how do you have a useful app when you don't have data? I'm going to explore some things that we learned at the Times about how to do this. So much of our crossword puzzle game can be enjoyed offline, and we've learned a few lessons from that getting there that I'd like to share with you. And we've kind of, or I have actually put some of this together in a demo app that we'll kind of explore, and the source code for this is up on GitHub, and there's a link at the end of the slides. Much of what we're going to cover is about how to do intelligent caching. So caching is awesome. Cache all the things. But not all data are created equal. And you should know thy data before you go and start caching. So some data your app revolves around. It's part of your business logic. Things like contact lists, game boards, maybe your progress as you work through a game or a book, maybe your favorites or your bookmarks, chat conversations. These are things you're probably going to have a persistent data model for in SQLite or in Realm or something similar, and that your core business logic is going to revolve around these. Other pieces of data are more ephemeral. To quote Blade Runner, all these moments will be lost in time, like tears in rain, that famous line. Things like search results, your activity stream, news articles, things that are still essential to the presentation and the functionality of your app. But you might not want to actually care about solidly persisting these things in such a formal manner as a SQL database. But they still matter because if someone opens your app in the subway and your activity stream isn't there, it's still going to be a bad experience. So here's a real world example with what we have in the New York Times crossword. So we have an API for fetching our puzzles, of course. We also have an API that fetches this landing screen with the featured puzzles and puzzle packs for the day. So we have a daily large puzzle, a little mini game puzzle, and maybe a set of puzzle packs that you can buy through in-app purchase that we're promoting that day. And our management on the team likes to kind of maybe switch up what we're going to promote pack-wise. If we have a sponsored pack or a brand new pack, maybe we want to feature that on the front page as opposed to rather in the packs tab. So the featured screen changes every day. And do we really need a data model to save this and persist it almost forever in a SQLite database? Maybe, maybe not. What we do though is a UI shouldn't have to care about how we persist it and how we got it. It just needs to know how to render it and do it well. So I've put together a demo app here for this talk. And again, the source is at the end of this for you to explore. But it opens up with a feed of cat pictures because, of course, it's you can long press on a picture of a cat to save it. So we can save a couple cats. And then you can pull to refresh and get more cats. We can go and hit the favorites tab and see the cats that we've adopted into our home. And then again, we can pull to refresh here and get a whole new set. And what's really cool is that if you open this app offline, you'll still get some cats, even if it's your very first time using it. So this kind of revolves around the idea of a repository pattern. So your presenter and your UI logic should be totally agnostic to all the inside baseball about how you get your data. Your repository, since it's the central place for getting data, is easily mocked out for testing. You just have a set of simple methods to mock out for getting back a list of cats. Rotation events get made really easy. You can retain the repository in a scope outside of your presenter or your activity. And so when your activity recreates, you get a brand new presenter injected, but since the presenter is stateless, you don't actually have any side effect from losing your presenter. Your repository gets re-injected, and when your presenter comes back, it goes and does a get on your repository, fetches cache data, and you saved yourself a network call, and the rotation handled, buttery smooth. And it adds simplicity to dealing with data because you have a single point of accessing your data. One thing that I've heard a lot at a bunch of talks this morning already was the single responsibility pattern, and this is another kind of facet on that principle of do one thing and do it well. So to help facilitate this, the New York Times has actually open sourced a library called Store, and this has been kind of primarily developed by the Newsreader app team, although we were one of the first guinea pigs for this on the Crossword app. And this library handles asynchronous data loading, caching, and orchestrating all of that for you, and kind of implements a take on the repository pattern for you. So this supports unidirectional data flow inbound from your server. It composes the whole act of making an API call against your backend, doing an in-memory cache, doing a disk cache if you want, and parsing. Maybe you don't actually care about disk caching, and being offline supported is not part of your use case, but you could still use the in-memory cache for facilitating things like easy rotation, because you have the ability to lean on that memory cache when you come back after your activity got torn down and recreated. The store gives you a convenient pattern called a barcode to address the data in your cache. It can identify the type of data and also pass your parameters to your fetching logic. So for example, if we're building a Reddit client and we want to use store to store the trending posts in a subreddit, maybe we'll have a key for Reddit posts and a value here for the subreddit that we want to fetch. And then that gets sent to your fetcher so that you can go and actually apply that value into the fetch parameters if you need to. And all of this has a nice, pretty little Arch Java bow tied around it. So it's a nice reactive pattern that provides observable you can subscribe to in your presenter that uses this. So a little bit more on the inner use of store. You get two primary methods, nice and easy, get and fetch. So fetch will go to the network to get new data, cache it, persist it to disk if you want that, and return it. Get will look at your local cache first, and if it's stale, then go ahead and fetch new. The network response will get streamed straight to disk into the persistence if that's what you want. So how do we build a store? Well, you're already familiar probably with retrofit and talking to an API with retrofit. So instead of having retrofit use a type converter for you, we're going to just go and get the straight up response body from OKHTP. So here's our cat API interface here, and we're going to go ahead and say fetch cat pictures, and that's going to go and hit the back end and get us a fresh set of cats. Now we can set up a store that actually handles composing all these things. So we're going to go in and this is kind of a snippet from a Dagger module in the example app. So we're going to go and grab our cat API that we've gone ahead and built with our retrofit builder. Kind of left that part out here because it's that part is standard as you're used to. We're going to go and pass in a cache directory, which in the example app we're going to use the applications cache directory. So first we grab our fetcher that we apply in our builder. So you have a callback that gets the barcode passed in, and your job is to return a buffered source out of that. So the network response from OKHTP can actually give you back a buffered source. So that's why we're going and calling a source in a response body. If we actually passed in params in our barcode, we could have used those here in our fetch cat pictures method. Since we're not actually using params for these, we can leave it empty. But if we were using our subreddit client, for instance, perhaps we would have picked off the subreddit name and passed that into our our fetcher. Next up, we want to figure out how we persist things. So the store comes with a bunch of pluggable interfaces for persistence, and one of these is a source persister. So we give it our cache directory, and then we also can give an expiration time for the cache. So here we're saying that we'll allow anything newer than an hour old to be treated as fresh with respect to the cache. Finally, you can drop in a parser. So since you didn't use a retrofit converter and a type adapter in creating your API, instead we drop the parser here. And this is because, again, we're taking the data directly from the network and persisting that to disk. So the parser here has now the responsibility of actually doing the conversion from the network response to your response types. So we actually have a nice little factory method from the store that gives you, JSON and give you back a response. And I believe there's also, if you don't like to use JSON, there's also a Jackson and Moshi converters in there for you as well in store. And finally, we call open to go ahead and build it. So let's go ahead and actually get something from the store. So it's pretty simple. We just have a get method now. Pass it the barcode. You have the usual subscribe on the IO thread so that we get our network traffic and our IO traffic off the main thread. We do want our work to come back on the main thread. And we're going to do something with our cat response that we get back. We failed to get our cats. We have a standard throwable that you get back, just like you're used to. So if the cache data is still valid from this get, it'll return it. Otherwise, it'll do a new fetch and give you that back. Now, what if we want to force a fetch? A great place to use this is in a pull to refresh pattern in your app. So your presenter might, in this case, actually go ahead and call fetch on your store and say, hey, let's bypass the cache and refresh. And you notice that literally the only thing we've changed here between A and B is get and fetch. So you're all the mechanics of getting the data completely obscured to your presenter or your view logic. So little snippet from the example here. We've got in our app, we have a view pager between the list of cats and our favorite cats. And so those are two fragments. So we have our cats fragment. We're going to go ahead and inject a presenter, so to get newed up for us by Dagger and dropped in. And that presenter lives in the fragment scope. We also have with our presenter, we're going to go ahead and inject the store. And since you saw in our earlier, we declared that store with the singleton scope, it's out of the scope of the presenter. So anytime that you get a presenter, you're going to get a brand new cat store. So that's great for unidirectional data or things that are more ephemeral. But for more permanent data, you probably want to consolidate that access into a repository of your very own. And so this is where you find yourself coming in with a persistence library like Room, for example, or Realm. So at that point, I would probably say you should write a data access object that handles all of the interaction directly with the persistence library. And if you use Room, which is a great new library from Google, it actually kind of enforces that kind of pattern of a data access object right off the bat because it even has you call it that with the annotations. So that would embody all the process of getting from the database, updating from the database, all your CRUD operations. So your repository would look at this and say, okay, and it's kind of limited to the kind of data you have, and this is, again, know thy data. So you need to figure out with your business logic, decide how fresh your local data is. So maybe this is how recently your contact list was updated, or in the case of maybe a list of crossword puzzles, maybe we have a new puzzle every day, and if we don't have yesterday's puzzle, then maybe we need to refresh. And then if you're up to date, return that data. Otherwise, do a network fetch, and then merge your local data with your data access object and return. And again, remember the get and fetch distinction, and that the point of your repository is to provide the same outer interface for everything and make it really simple so that your any logic that uses the data doesn't have to worry about the inside baseball. So another kind of use for the store is to handle the experience of loading first when you're offline. So definitely you don't want to have a situation where somebody downloaded this app because they heard, oh, I heard about this great app that lets you look at cats. And they've come down and they've gotten in the subway train and they've decided, hey, I'm really bored. I just downloaded that app about cats. Let me check it out. Open it up, and you get an empty screen. That's no fun. You'd think it's broken, you'll one-star it. So how do we mitigate this? And this is kind of a real-world example of this is in the New York Times Crossword app. We want that featured screen to have some sort of data that you can use right off the bat, even if you're offline. And so we actually have a canned set of puzzles for you to play that we pack in. And kind of here's part of how we do this. So imagine we have a preloaded response from our cat API. So we're going to simulate that response, but we're going to change where the images are sourced from. So if you're not familiar with the concept of Android assets, you'll find this in your Android Studio in the assets folder. You can go and drop things in there. And they can be addressed through a URI. You can point Picasso at one of these URIs, for example, or a web view, and it will render. But these assets don't actually live as files. They're actually streamed directly out of the APK package. And you have the Android Asset Manager gives you some libraries or gives you some methods for getting those streams out and doing work with them. So how does this help us? Well, we can go and drop this preloaded cats response right into our asset directory, as well as these images. And now in our applications on create and our very first load, we might want to go ahead and drop these preloaded cats right into the cache. So the store by default with the persister will go and drop the network cache in a file which is named by the toString of your barcode. So we can kind of cheat here and forcibly add a brand new cache to set that up. So we're going to get the barcode that we want for our front response. We're going to go ahead and open an input stream from the asset manager with the data that we want. We're going to write that right into the cache. And since we don't want to end up stomping on someone's cache every time you open the app, we're going to go ahead and set a shared pref to use this for a means of making sure that we don't do it every time. Now, maybe if you want to update the app and provide a new preloaded file, maybe using a true a Boolean for your shared pref isn't very good. Maybe you want to look at a timestamp or something like that. So you can say, okay, well, is my cache newer than this? No. Okay, let's drop our fresh, hot new cache value in for this revision of the app. So, but what we end up doing is we warm up the cache with an initial fake response. And so even if the first time you open the app, you're going to go ahead and get that data, and then we'll be able to stream those cat images right out of the asset folder. So another dimension of knowing your data is fun tricks to use your cache and handle updates. So when does your data change? If you're running a chat app, for instance, it's pretty simple when your data changes. Someone sends you a new chat message, you can send a push notification to reflect, hey, I have new data. If your user's offline when you get a push, they'll catch it when they return, and your push receiver can do a fetch to freshen up your cache. One thing that we have on the iOS version of the Times Crossword that we don't yet have on Android is, we actually deliver our puzzles and have a push notification that comes out, so we could go and do a fetch to sync up local data when we get a new puzzle notification. You also can use Job Scheduler or Firebase Job Dispatcher to schedule some friendly background syncs. So for instance, Job Scheduler exists in the Android SDK from Lollipop forward. Firebase Job Dispatcher is an open source that works from API 9 forward. Lets you request a sync by time or when the user has network access, when they're charging, etc. So maybe if you have new data come out every day at the same time, you can schedule a job to go ahead and do a sync. You can also use the network triggers to do things like send back local changes that will happen when the user's online. So if I've marked a piece of puzzle progress as dirty and I need to send that back up, I can use a scheduled job with a network qualifier to make sure that if you have network, great, we'll send it now. If not, we'll hold on that until you have you're back online. Another handy thing to do is to pull down your user's home screen activity at night and warm up the cache. That way they open up the app every morning and have a fresh set of data. Real world example of that here is in the New York Times news app. Actually, we have a job scheduler that refreshes the latest news. Runs at 6 a.m. and 4 p.m. Why do we do that? Freshen up people's caches before their morning and evening subway commute. Architecture for the subway in action. So if you remember me from DroidCon last year, I gave a talk on sync adapters. So you might ask me now, sync adapter or job scheduler? Hey Ben, what would you pick? So sync adapters are great. They provided a battery-friendly, network-aware background syncing framework. But they come up with some overhead of accounts and content provider. And they don't give you some of the flexibility that a job scheduler gives you, such as being able to specify an actual hard window in which your sync can happen. So for instance, you can set a time window from 6 a.m. to 6:59 a.m. during which a morning sync should take place. And if you don't have Wi-Fi or otherwise don't meet the constraints to run that job, it just won't do it. And sync adapters don't really have that kind of flexibility or additional control on when you want to run a job. They also come with the kind of overhead with creating a content provider, even if it's a dummy content provider, and creating an account that shows up in the user's settings. If you look at probably on your phone right now, you'll find half a dozen accounts listed for apps that are using sync adapters under the hood, and they're only there because they have to have an account there. But like I said, Job Scheduler exists on API 21 and later. Firebase Job Dispatcher works on API 9 and above, but it leans on Google Play services for much of the span of its compatibility. It uses the built-in job scheduler from 23 forward, and before that, it uses a pattern from a Play service called the GCM network scheduler. So it has a dependency on Google Play, even though it exposes a very similar job pattern, API pattern as the native job scheduler. So now you're kind of in a situation where if you're supporting non-Google devices less than API 21, so maybe some older Kindle Fires or your user base consists of people who are running non-Google Play operating systems, custom ROMs, things like that, maybe a sync adapter is still a good option there. But otherwise, I would really consider looking at Job Scheduler. Either way, what's really nice about this is you get a service context in which to run your sync logic. So it's a great place to do to componentize and kind of limit all of your background sync to one place. Again, single responsibility principle in action. Your sync service does one thing, talks to the repository to do these sync data. So with that, you'll find some of the New York Times store on GitHub, and then also I have the source to the demo app here, tinyurl.com/offline-cats. And with that, I will open the floor for questions.
Can you go back to the other slide?
Oh, yeah. Didn't mean to hit that one.
Oh, hey, I was wondering, could you talk about media caching, like images and videos? Would you use a job scheduler to store videos, downloads, and would you just toss in like a Fresco cache, or would you do something more?
So, one thing that's kind of handy is I know that Picasso allows you to essentially do a download without actually putting it into a image view, but you can warm up its cache that way. So that might be a handy way to do it. To tell you the truth, I haven't had to work with video caching, so that might be something I'd have to think a little bit about. That's that's actually a little maybe out of my experience actually. Well, thank you very much.